Hello fams, welcome again. It's your Dr. Tutor from DB Tuitions, and in the series of GCSE Chemistry, we today are going to talk about chemical symbols. Now, I'm just going to pause here for a few seconds so I can give you some time for you guys to open up the periodic table. If you have landed on any of my previous videos or this is your first video, you will be learning along with me in this series, as in real time, as if I'm actually teaching you live. So I'll give you a couple of seconds to open up the periodic table. If whatever board you are, you can type in GCSE AQA or GCSE OCR, GCSE Edexcel and the periodic table, and I would suggest to follow the exact one what you would see in the exam. Now, what are chemical symbols? Now, all the elements you're seeing on the periodic table, the 118 of them, there are some letters and numbers in those grids. Each of them represents an element. Now, what is an element? An element is a pure substance which has only one type of atom. So it has all same types of atom. For example, if I take, let's say, sodium. Sodium has atoms of only sodium. And each element is differentiated by its unique number of protons. Now, fams, let me tell you here. All the elements you're seeing in the periodic table are represented by a unique symbol, and you can see them on the periodic table. Now, in the periodic table, the horizontal rows are known as periods, and you can see vertical columns which are called groups. I will come to them in a minute, but we will go back and learn about, now we have learned what are the atoms. If you haven't, there is my video, What the Atom Flip. So all of my fans are welcome to go and watch that video. And here is a continuation in that series explaining what are the chemical symbols of elements. Now here I'm going to take an example of carbon. Right? So, carbon has the chemical symbol C. Now, you will see two numbers in the periodic table, one a bigger number and other a smaller number. The bigger number is known as the mass number. Now, what is the mass number? And it is very weird, isn't it, fams, to call mass and number. You would, in your mind so far, anything mass is how much it weighs. And you're right, it's exactly the same with the atoms as well. So this number is representing what each atom of carbon weighs in terms of units. That's why we call it mass number. And deeper into the lessons, we will understand a bit more about it. And the smaller number represents atomic number. Now, this is the number of protons. Now, if you remember, the mass of every atom, as I explained you earlier in the videos, is concentrated within the nucleus. And that's what is our mass number. And within the nucleus, we have protons plus the neutrons. Now, it's very easy to work out the number of electrons, protons, and neutrons in any given element. For example, now atomic number for carbon is 6. So therefore, the number of protons are 6. Now, mass number for the carbon is 12. To work out the number of neutrons, I'm going to take away the atomic number from the mass number, which is 12 minus 6. which gives me 6 neutrons. Now what is left is electrons. Now I want every one of you to pay attention here. Atom is electrically neutral. What does that mean? Remember that fight when a couple of your mates had and you did not take any one side? You were neutral. So you said, I'm not going to take any one side. That's how atom is. It's neither going to be positive nor it is going to be negative. It is going to stay electrically neutral. So that's why it will have same number of positive charges as the negative charges. So therefore, protons represent positive charges, electrons represent negative charges, and because it's not taking any one side, it's neither positive atom nor negative. So therefore, it will have equal number of positive and negative charges. Now let's follow this up with another example. Now you're going to work out with me. I am going to write 3 elements on the screen. Okay? Now, I've written sodium, then I've written magnesium, then I've written calcium. Now remember, the heavier number is the mass number. The smaller number is the atomic number. The mass number is the number of protons plus the neutrons, and the atomic number is proton number only. I'll give you 2 minutes for you guys to work it out in real time, and then you can pause the video here and restart. Good luck. Hope you guys have worked it out. Now, let's see. The bigger number for sodium is 23. That is the protons plus the neutrons. And the smaller number for sodium is 11, which is proton only. So therefore, for neutrons, we are going to take away the bigger number. You're going to take away the smaller number from the bigger number, and then you're going to get your answer, which is the number of neutrons, that is 12. Now remember what I said? The protons and electrons in an atom are equal because an atom is electrically neutral. Well done for remembering that. So therefore, the number of electrons in sodium will be equal to the number of protons, which is 11. Therefore, we have now found out the number of protons, electrons, and neutrons in sodium. Similarly, you have to calculate in magnesium and calcium. The number of protons and electrons in magnesium would be 12 each, and the neutrons would be the bigger number, and then you're taking away the smaller number, which will be 12 as well. Hopefully you got that right, fam. And then for calcium, you're going to have the number of protons as 20. Remember, atom is electrically neutral, same number of positive and negative charges. Therefore, the number of electrons are 20 as well. And then finally, the neutrons, you will take away the bigger number, which is the mass number, and you will subtract the atomic number from the mass number, which will give you 20 neutrons. So this is how, fams, all of you have learned today to calculate the number of protons, electrons, and neutrons. And also you've learned about all 3 subatomic particles and how to represent chemical symbols. Hey, one more small bit before you go away. Now, you can say, Tutor Doctor, what's happening here is some of the elements have 2 letters in their symbol. You have told us about carbon, which is only having a single letter. You're absolutely right. Out of the 118 elements, few elements are represented by a single capital letter. For example, carbon, oxygen, nitrogen. But if there are 2 letters, let's say like sodium, you can see here the first letter of the symbol is capital, but the second letter is in lowercase. So any symbol which carries 2 letters in its representation, the first letter is always capital and the second letter is lowercase. That's the end of the video, fams, and I'll see you in the next video within the series. Take care.